Hello, everybody. Welcome. Welcome to Cleft, an art and engineering collaboration. Welcome to the in-person audience here in the Center for Art, Design, and Visual Culture, as well as to our virtual audience on YouTube. So for those of you on YouTube, please note that closed captioning is available on YouTube. To start, I'd like to acknowledge that CIRCA and UMBC was established upon the unceded tribal lands of the Piscataway and Susquehannock peoples. I'm Lynn Kazabon. I'm the director of the Center for Innovation, Research, and Creativity in the Arts at UMBC. CIRCA is sponsoring this event in partnership with the CADVC. I just want to mention before we start that CIRCA is hosting other virtual and in-person events this semester. Please just visit the circa.umbc.edu website to learn more about those events and to register to attend. So I'm going to do the intros for our panelists here. I also want to mention that if you are watching on YouTube, you can type questions into the chat, which we will get to at the end. And then, of course, the in-person audience can ask questions in person. So first, I would like to introduce the artist here, Annette Cowenberg. She's the artist behind this amazing exhibition behind me, which I encourage you to come and visit if you haven't already. Annette is the recipient of numerous grants, awards, and fellowships, including in 2014, a very prestigious Smithsonian Artist and Research Fellowship. Her work has been exhibited nationally and internationally, including at the Homa Museum in Seoul, Korea, the Museum of Arts and Design in New York, the Delaware Center for Contemporary Arts in Wilmington, the 28th Street Studio in New York, the Decorative Arts Museum in Little Rock, Arkansas, and the Textile Museum in Tilburg, Netherlands. Her work is also in the permanent collections of the Baltimore Museum of Art and the Textile Museum in Tilburg, Netherlands, among many others. Annette is on the faculty at the Maryland Institute College of Art in the Department of Fibers, and she received her graduate degrees from Cranbrook Academy of Art and Syracuse University. Next to Annette is Alan Grover. He's a professional programmer who worked on the project. He's currently working in the open source world. In recent years, he has been a technical assistant to several artists and also to classes at MICA. Next to Alan Grover is Dr. Tim Topolowski. He's a professor in the Department of Mechanical Engineering at UMBC. Tim's research is focused on biomaterials, both materials that are manufactured to be implanted in the human body and understanding human tissues as materials. Next to Dr. Topolowski is Miles McVeigh. Miles was one of the UMBC mechanical engineering students that worked with Annette on Cleft, a sculpture behind me. Miles hails from Bel Air, Maryland. He currently works at Aberdeen Proving Ground under the Radio Frequency Communications Division. And finally, the moderator for this discussion will be Lori Rubling at the end. Lori is the curator of this exhibition. She's also a professor of art and communication design at Stevenson University. So take it away, Lori.
Thank you, Lynn. Very exciting. Welcome everyone from the YouTube virtual universe and everyone in the audience. Our general questions or conversation we want to have tonight is about thinking about collaboration. So as we move along and start the conversation, certainly I'm prompting all of you to think about how you understand collaboration and maybe ask us more questions about it or share with us some insights with you. Fair enough. So Annette, we're going to start with you. And by the way, I'm not checking my news feed tonight. My questions are on my phone too. How many disciplines intersect this project, our Cleft animation project, do you think?
That's a good question. Cleft is a sculpture. It's not yet, but almost an interactive sculpture. So that's another discipline. And it actually has a lot to do with engineering. Programming, another discipline. And I think that for me, I feel that disciplines have a limit. Every discipline has a limit. And I feel more and more that if we want to have some kind of say about what technology is doing in the world, that we need to be at the table. And I do that in my teaching, and that's how I got to this project. I teach a class, it's called Unravel the Code, for the last 10 years, where we are collaborating not only with people overseas, but with students, engineers, Ellen is in that class, software developers, to really see what technology can do. And what we look most at is understanding the intersection of craft and emerging technology and how they can feed each other. Is that?
That's good. How would you define collaboration?
As I said before, I do feel that every discipline is limited, and I have an curiosity that never stops. So if I have a curiosity that never stops, I need to start listening to other people, working with other people, and I see it as an collaboration, as a linking and emerging of interests, but not only that, but mostly questioning each other and trying to understand the language that another discipline is speaking. And through that, entering a piece or a concept through another door where I can learn. So that's for me what collaboration is.
Okay, good. So, and why did you seek this collaboration with Timmy and the engineering department?
As I always say, I'm an artist educator. I'm not just an artist. Part of my life is education. And I love being in the classroom. I love being connected with the younger minds who are in some areas farther along than I am in the sense of understanding. And when I said to Sims Gardner that I would love to work with the engineer department, Tim immediately stepped up and said, yes, let's do this. So it's been quite an experience, although we had to do this during COVID. But it was quite an amazing experience.
Cool. Thank you, Annette. Timmy, what would you like to say? How would you like to get started in introducing your relationship to the project?
Well, hello, everybody. Thank you all for coming. So picking up where, where Annette has left off, give you a little idea of my history with the project, and then how Alan joined us as well. I've known Sims for quite a long time. In fact, I think I'm supposed to be on the advisory board for the, the CADVC. And so Sims reached out to me and said, we have an artist who's got an exhibition in a year. And I said, oh, great, a year, that's a lot of time. And little did we know. And I said, yeah, let's find out what's going on. And so Sims kind of described the project to me. And we have a class that our seniors take. It's ENME 444. It's called our capstone design class. And the class is structured such that student groups work with clients. And I've been a client of the class many times and had students design things. They also work with other organizations, for example, the Volunteers for Medical Education. We do a lot of work with people like that. And so I proposed to Jamie Gerganis, Dr. Gerganis, who is the instructor for the course. I sent in my proposals for projects, hoping that a group would bite. And apparently, and maybe Miles can tell, there was a little bit of fighting over it because a couple people wanted to join the project, and Miles' group was able to pick it up. And we can talk to Miles about what he did the first semester. That would have been the fall semester of 2020. And then they brought it to a certain point, and we still needed more. And then we offered it to a group in the spring of 2021, and they took over from where Miles' group left off and brought it even further. You know, in the meantime, Annette had been in touch with Alan, our electronics and programming wizard, and Alan started looking at how to do the electronics and really make this move. And so I think it was a little bit with the first group. Now, the first group was starting from scratch, and we did have team meetings during that time, and they really brought us to the point of understanding where we needed to go with the project. And then the second group was able to come and pick up from where Miles left off, where we really had, I think, a clear direction and take it from there. So I think we had more meetings with the second group with Alan, Annette, myself, and Lori. And that's where we started discussing, you know, what did we really need to make Cleft work? And there's a couple things I realized probably a little late in the game. The first thing was that Cleft was not designed for this, I think. Cleft was originally exhibited on the ground, right? And so we were dealing with more of a retrofit project than from a ground-up project. And that presented some unique challenges to us. We can talk about those details later. But and trying to understand how we could achieve Annette's vision, you know, within the constraints that we had with what Cleft was. So I'm going to turn it over to Miles in a second, if you don't mind,
That's
Lori,
great.
to
Please.
pick up from there and maybe ask you some questions, Miles. We first saw Cleft in pieces. So that was another thing. We never had Cleft completely together until I think about a month ago, and that showed us where we needed to go further. But I wanted to thank some people, if I can do that now, that aren't on the list of the sewing circle and that helped us out. So first of all, Richard Jenkins, who's in the second group that followed up, came in a couple times this summer to help me. He was a big help. A couple of students, I would offer it to the students. Anybody that wants to work on the project, I could use your help. And a couple of students came in for a day and maybe just turned screws or held things, including Liz Muller-Knoll, Noel Ray, Justin Gruhovic, Nathaniel C.A., Dr. Gerganis was here, my wife Marcy Chasnow, and especially my daughter Audrey, who was a real companion over the summer. I would come in and there'd be alone here in the other room back there, and Audrey and I would be working on different pieces, and she really came up with some really interesting ideas. Why are you doing this? Why are you doing this? That was fun. But two people that were incredibly pivotal to the whole thing were Karen Roulette, who's an administrative assistant in my department, and Karen did all the ordering for the parts for both Alan and I. And not only did she just do the ordering, she followed up. And I think without Karen being so dogged, we would not have Cleft as it is now. And then Hank Mink, who is the technician in our department, who helped put the original frame together that we then modified. He did all the parts. He cut a lot of things. I would ask him, Hank, I need 3 pieces about this big. And he would have them ready for me, and without those people, we wouldn't have made Cleft what it is. So I just wanted to give a thank you to those folks. So Miles, now to you. Do you remember what your initial impression of the project was like?
I think initially, 'cause I'm trying to remember the description. I think we saw it was like origami type artwork that would be, I think the description was just, we want to move origami artwork. And our group went, yeah, that seems really cool. We want to work on that. And then, I guess getting into it, once I think you showed us a couple of the pictures of it on the ground. We were, I guess, pretty excited. to be able to work on something that we would have to puppeteer from the ceiling. It was a very, I guess, interesting engineering project from just the description alone.
And where do you think you brought the project to? What was your sort of endpoint?
I think our group managed to, I guess, we brought the project to a point of understanding, I guess, the layout that needed to be done in the ceiling, probably what would need to be done for some of the wiring, like the electrical, what would be needed for the stepper motors, or at least what we knew worked, which, so I think we brought it to a point of, I guess, understanding where the, I guess we got it working for a single segment of the sculpture.
I think Laurie's showing us a video of that
Oh,
right now, the single segment.
yeah, so I guess that would probably be our biggest, where we got it to. We were able to show that we could make it move for a single segment, and we knew how to control it for a single segment, and we figured that was a good step to prove that this design could be taken forward and be applied to multiple segments, and hopefully then work in its entirety.
And I think you also did a lot of analysis just on the motion to make sure it didn't go wild,
Yep.
right? To stabilize that single segment, which, you know, of course, when there's, it's a lot different when you have multiple segments, but that really gave us the idea that we could, I mean, just how to hang the segment. I think you also worked a lot on that.
Yeah, we did a lot of statics. That was it's a lot of balancing of forces and moments, and then pairing that with, can we do this? And okay, yeah, it will work theoretically, and then okay, we know it works theoretically, so how do we tie that into the geometry? So where does it have to hang? And then from there, actually doing the testing and going, okay, well, this is everything the model says, but the model's ideal and it's not real. So our biggest concern was, I really wasn't sure how rigid those segments were going to be. I was super concerned when it went to pull up the one end, it was going to dip in the middle.
Mm.
So I'm very glad that didn't happen. But yeah, we did a lot of work to try and verify that the what we were going to build would work, because we didn't want to jump into it blind and then realize, oh, this doesn't work, and now we have to redo everything.
Good point.
But
Beautiful. Thank you, Miles. So I'd like, Tim, I think we'd like to hear from Alan for a couple minutes, and now we're going to get kind of work from very broad to going deep into the systems engineering and programming for Cleft. So Alan, it's all yours.
Thank you. Please pardon my notes. I'm not a lecturer, so I need a little help. So it was well over a year ago, Annette asked me about doing this. We had talked about a couple of other pieces of art, including video back in the corner, this kind of motion. So this has been going on a while. The obvious solution was to use an Arduino and a stepper motor. So that, in fact, is what we ended up using. There's 15 of these up there, and one of those to control it. And we talked about interactivity. She really wants it to have some interaction with the audience. But in my role as an engineer, I said no. Actually, I said we couldn't do it now.
Right.
I knew there was a lot of work to do. So we are planning to add that in. Oh, sensor. Wait, I have one. So here's a tiny little sensor. This is actually a tiny camera with really low resolution, and it's actually infrared. So we're hoping to use 3 of those. Sure. This is a case of we don't know how well it's going to work. A lot of these kinds of projects, they're one-offs. You know, you only build one of these, and you can only bring so much experience to them. So there's a lot of exploration often in trying to get this stuff to work and figure out what strategies will work. I suppose I could make a list of all the things that broke and didn't work as we did this. It's quite long. I want to emphasize that despite the collaboration, this is Annette's piece. This is her vision. She has a lot invested in this of making it and what she wanted it to be. And I felt that my job is to help realize as much of that vision as I can. So I had to keep asking Annette, you know, what do you want? Do you want it to be like this? Do you want it to be like that? Trying not to say no too many times. When I'm in this class, we have anywhere from, how many students have we had? 15 to 20 something?
30.
And, you know, they have to fit it within a semester, right? So they're trying to get their scope the right sized, you know, is actually something important to do. I think Lori asked about collaboration earlier and what is collaboration, which made me think a little bit more about it. I know that when I collaborate with people, I'm much, much smarter. I'll come up with an idea, but if I discuss it with someone else, they'll often come up with an improvement or a better idea, and back and forth. And I feel like it's very dramatic. I've seen in my professional life that if I collaborate with somebody, you just get much better solutions. I really enjoy collaboration because of that. Yeah, I can take a little bit of credit for being smarter. I thought I'd talk can I talk a little bit about the technology
please. Yes.
beyond this?
Yep.
So it's a little bit of a challenge to make this device control 15 motors fast enough. So you can like wave that at them, yeah. You can't really see it from here, but you're welcome to come look at these things. And there's a few images back here in one of the cases that show some of the other stuff. Oh, I suppose these images have been running behind me. I didn't notice. Yeah, oh, that's a nice one. So I had to use shift registers to get enough outputs to talk to all the different stepper motors. I had questions like, was that even going to work? Was it going to be fast enough? So I had to build prototypes. I think there's some images in here of 2 or 3 levels of prototypes. There's one. Nope, there's one. There's one. Okay, they're going fast.
Is this good?
It's fine.
Okay.
There's just lots of bits and pieces in there. It's good. I designed a software framework to coordinate everything and leave space for putting in the sensor system. All of my code is up on GitHub. Everyone here knows what that is, obviously. It's a place to share code. I asked Annette if we could make it open source, and she said yes, so it's fully open source. I don't know how reusable it is to other people, but I like putting it up there. Do you have that animation, what I call the emulator, the visualizer?
I shared it once, I'll share it again. Yes.
We didn't have the motors until quite late. We didn't have the motors installed until really, really late. And we didn't have Cleft hung on the motors until really, really, really late. I'll tell you a little bit about how late in a second. So I had to come up with a way of knowing that my program was doing something useful. And this little visualization program I thought would be, oh, that'll be convenient. It turned out to be really important because we didn't have a real system to test on. So like a decent idea turned out to be a really, really good idea for me. During this collaboration, Tim mentioned bringing in students and some other people to help. We had a soldering party. Several people here, Sylvia was there, Lori was there, Annette was there, some people weren't here. We sat around and soldered up some of these parts, like that kind of thing. That was great. There's a lot of work. I don't know if, that doesn't even show all the wires that are in it. There's a lot of wires up there. And I want to give a special acknowledgement to gaffer tape. When we were putting everything on this frame up here, which you were encouraged to look at, Annette, in fact, told us that she wanted it to be, visible, that people could see that there was this kind of technology up there. We use gaffer tape a lot to position items, hold them in place until we could get to them. Nice stuff. It's like what duct tape is supposed to be. I'm still kind of amazed that Annette had the faith she did in us to do this for her. She was doing a tremendous number of other things, especially here toward the end. She had never seen cleft off the ground. She saw it on a table. She had never seen it hung in space. She had never seen it move until, 30 minutes before opening, you walked in the door? She trusted us enough to get this, to get her vision close enough. I think that's pretty amazing. If it was my piece, I would have been crazy. I could have not tolerated that. But she was great. So next we're gonna try to get the sensors and some kind of animation up there. I actually have no idea how that's gonna work. I mean, I have some ideas, but I'm not sure how well these things will work or what they will do yet. Okay, thank you.
Thank you, Al. Good. So we're ready to take your questions. Yes.
Two-part question for Annette. I'm just curious about your intention. So why and how did you want it to move?
Very good question. My work comes from the body and became sculpture. But I always think about the interaction of those two, of what the body does to it. My research, just to give a little background, my research at the National Museum of Natural History was in looking at the interdependence of the skeleton and the skin in the fish department. So I started to really think about evolution and how things grow, how things move, how that influences not only what it looks like, but how we feel about it. So I really had this dream that I wanted something that I could walk into and that it would, and we will get there, that I can then start influencing it. So that's really what the dream was about. And another part is that, I trust people next to me and I want to work with people who really want to see this vision happen. So I sometimes had to say, yeah, that's fine. It's okay if that doesn't work exactly the way I had seen it. So does that answer your question?
And your second question, or did she?
It was the why, but how did you want it to move? Was this the interactive part?
Yeah, I definitely wanted to be that the audience becomes the digital puppeteer, partly because I feel that technology is taking us over. This vortex of information that hangs around our body, we constantly have this thing in our hand that is not only broadcasting, we are broadcasting, we are receiving. So there's this constant buzz, this vortex of information, and I wanted to have the audience to think about that they are in charge through the Arduino, through the microcontroller, that they can move the piece in a way, and that the machine is partly an extension of us, or are we in charge, or is the machine in charge? So I hope that that question comes up.
And Annette, just, I could add to
Yeah.
that. Annette, over the summer, she gave several papers, and clarity was, one gains clarity when you have to synthesize and simplify your thinking, right? And Annette's very much engaged in realizing how the machine, how computing, right, our computers are becoming thinking things, right? And through just obviously algorithms, but it's a line of inquiry that she's starting to really wrestle with and pursue more. And I think this, the cleft animation is the first
Yeah.
iteration of that,
Yeah.
right? And the other really interesting thing is none of these works are ever finished, right? It's just iterative, as Annette's experimentation and integration of material questions she's asking, they just evolve, right, into the next thing. And I would definitely say we saw that here in the group of us working, but also in her Unravel the Code course, which she co-teaches with Alan. And that's a group of 15, 20 students over the course of a semester. And the iterative process, right, you have times 15, right? So one's direct knowledge of a system or a test of something, right? You're seeing it times 15, times 20, and it's invaluable, right? She doesn't necessarily have to do it herself in order to gain some insight, and then she starts to ask the question, well, how might I use that, right? And how does that build on things?
Yeah, and I think that we need to learn to see what the computer sees, I feel. If I want to understand the computer as an interface, as a tool, then I need to start thinking about how does the computer see, and how algorithms work help me understand that. And the other thing is I'm really thinking a lot about what Douglas Rushkoff says, are we being programmed or do we program? And if we're, can I start understanding that to the point that I can then have influence on it and have it as an interface, as a tool? And I think we have to, because if we want to have influence on where technology is going, then I need to understand a certain part of it. And anyway.
Good.
That
We
makes
we
any
have a
sense.
question from home, Sylvia, so can we, or did you want to follow up with that question? Yeah. Okay, good, okay.
When we spoke about your work this summer, you said something like, well, you can think it up and make a design on the machine, right? But then when you're actually working on it, other things show up. And I found that rather interesting, how you deal with those. Maybe you can give some examples.
Thank you.
Yeah, I think that's, I come to this work as a textile artist, and a textile artist is extremely interested in process. And so process gives me a knowledge that I won't get from just looking at it. And I think about two things. If I think about knowledge, it's a little box, or just a square. But if I think about knowledge, making, embodied knowledge, I'm thinking about a very expanded box, where there's a lot more information for me to understand that. I mean, these 6,000 receptacles in the finger actually will take in information that I otherwise not get. So I feel very strongly about making, and I call it research through making. It gives me different information than just reading about it or looking at it, so I think that that's really important for me. Does that answer?
Good.
Okay.
Thank you. We have a question from
Yeah.
the YouTube audience from Woodrow. Beyond the more transactional contributions of the engineering collaboration, what else could these sorts of art and engineering collaborations offer in influencing how engineers think and act? For example, could the questions the work evoke have engineering education implications? What a great question.
Yeah.
Thank you, Woodrow. Could would like to answer that? So I'll restate that, or maybe you could answer that. Miles? Okay, so I'll just, so this, for example, could the questions the work evoke have engineering education implications? Okay.
Sorry, could you restate that one more
Sure.
time? Thank you.
Yes. So, what else could these sorts of art and engineering collaborations offer in influencing how engineers think and act?
I definitely think that these kinds of collaborations, on one level, it makes you start considering a lot of things. Speaking from my experience during the semester when we worked on this project, there's things that in previous design classes we didn't think about or didn't give as much attention to. Things like the noise that gets generated from the motors, or have the visibility of what you're making. How does it actually look? Does it look pleasant? Does it look unpleasant? It's stuff that when you're working on things sort of from a almost purely engineering standpoint, it's more, at least in most of my experience, it's all about function. It's how do I get this to do what I want? And there's a lot, I think, that our group learned from working on this, of not just the function, but also the form. And can we sort of combine the two? And there's a lot to think about there. It introduces a lot of interesting trade-offs of this looks nice, but maybe it's not as strong, but maybe we can compensate for that in some way. So I think it helps kind of offer a new perspective in that not just getting it to do something, but getting it to kind of look a certain way.
Cool. Timmy or Alan, I'm interested in your answer to this.
I want to hear from you.
Oh, well, it's a really interesting question. And I think what a lot of people may not realize is that most engineers, good engineers, appreciate the creativity and the process of art and are very interested in understanding how it works. And most artists also appreciate the engineering and the technology. And this doesn't have to be fancy. One of my favorite examples is that the Impressionism, the French Impressionists, that would not have been possible without three technological advances, little tiny things that happened at the time. One was a chemical stabilization of the purple and blue pigments from the cobalts. Another was the invention of the portable lead refillable tubes for the paints. And the third was creating a collapsible and portable easel and chair. And without those things, these artists would not have been able to go out in the field and paint water lilies and the potato farmers and things like that. And so I think there's an appreciation on both sides, but oftentimes we don't get to work together because there's sort of an artificial separation. We're in the engineering building. We've got things to do. Build cars, make sure we build and maintain the world, make sure your chairs don't fall down. The artists are in a different building. They have things to do. They have to create beauty. They have to fill space. They have to think about things. And for some reason, we don't get together enough. And I think that is one of the questions, or one of the answers to the questions. What are the implications for engineering education and art education is to get us together more often to work on these types of projects. I think the students are just incredible evidence of how successful it can be for educating people on both sides. And then, for the three of us to be able to work on this was such a treat for me. I would go in and there's Cleft, and I won't tell Annette what I did with the pieces, but it's very durable. Let's put it this. I mean, For example, I mean, I knew I could get another piece of aluminum or some more bolts if I dropped it, but I also knew I couldn't get another piece of cleft. I mean, Annette could repair it, but you know, it's a one-of-a-kind thing. So I was the guardian of this thing for quite a while, and that in itself, to be able to spend time alone with the sculpture in pieces and in parts, for me, was an incredible treat, and that kind of inspired me to do my best. You know, I would you know, be up all night worrying about something. How am I going to hang this way? And then a couple of days later, a solution would come, and I'd tell my wife, "Oh, I can sleep now. I figured it out." And then, you know, interfacing with Alan on how to how to fit the frame and the electronics together. I mean, just making sure that we could do that. What do you think about the question, the engineering and education, and how this can?
I have a very troubled relationship with my profession. My background is actually very engineering heavy. My father was an electrical engineer at Heathkit, which means something to like 3 people here. And I was tracked into math and sciences, but my actual college degree is in anthropology, because I knew I had wider interest in the wider things. And a lot of the trouble I have with my profession is engineers tend to focus down on things. And I think he kind of mentioned they're trained in more of a utilitarian, functional sort of goal. One thing I found out is that they're trained to pick very safe solutions, kind of in the middle of the solution space. I think they're told pretty explicitly to stay away from the dangerous edges of things because it's unreliable. And an engineer's job is to make something reliable. Working with artists, they approach things very, very differently. They start maybe with an idea, whatever their starting point is, and their urge is to expand out from that, to use that as a leaping off point to find something else. That drives engineers absolutely crazy. I've watched engineers try to work with artists. It can be very difficult if they don't understand that dynamic. I've heard lots of stories from various institutions where they have managed to have these programs where they integrate engineers and artists. And the stories sound really great. They work with architects, or they work with artists or designers or whatever. And the outcomes sound really great. I agree with Tim. We need to do more of that.
Woodrow agrees that he commented on your comments. Let's bridge this divide. So I agree with that. Yeah.
Yeah, I said I was troubled with my profession. Good luck with that.
Okay.
A lot of engineers are difficult. If you'd like, I can tell you all about it.
Privately or
later.
afterwards. Yeah.
Yes.
A question from the audience, from an in-house audience. Yes.
The speaking out issue, I was wondering if you could all say something about both artistically and engineering perspective about the scale of the project. Because my understanding is it started off with sort of being modeled on a collar for a human, that
Slightly bigger than the collar.
you have in mind for that, but
Yeah.
I'm just wondering decisions about scale, both the artistic aid for doing that, but what sort of engineering benefits or challenges that might have had.
Okay. So we're discussing the scale of cleft, which is an approximately 8-foot diameter object with an opening where a cleft in the neck would be. Annette?
I totally agree with Alan. You have to go to the edge to see, and I think that that's a methodology that artists use all the time. We walk on that edge of success and failure, and that's what we want. So in 2003, I did my first 3D drawing in the computer space, and it looked so good on the screen. But then I was like, but I want to walk into that. So that's a long time ago. So I always felt that what I see on the screen should be possible to be life-size. And this is more than life-size, but I want to push that edge constantly. I wanted that piece that I did in 2003. I was dreaming about that I could walk in it, and here it is. And I have to be honest, because Alan doesn't give himself a lot of credit. At the moment I walked in, and I had seen the piece in between, we had moved it, with the students for once, and then, but when it really was up, I actually literally cried. That moment of the emotion of seeing something that you had thought about, that you were dreaming about, and you have people who are sitting around here who are working with you to make that come true. So from now on, I call Alan my guardian angel. So there is something to say about engineers who solve these incredible dreams for you. And it is, if we make it small, it is for me not about that moment of the real confrontation, but the moment that I make it big, it becomes a confrontation that becomes physical, embodied. If that answers your question.
Thank you. So we have another question from our YouTube audience. George asks, has there been any discussion about a student collaboration between Professor Tobolewski's UMBC engineering class and Annette's Unravel the Code course at MICA? Tim?
I think the last couple months we've focused on making sure we could get Cleft up for the exhibition. And I think we kind of left that behind. But early on we did. We talked about coming to each other's classes, for example, and just starting to see what we do in class, and try to find those areas where we can get students to interact. I mean, I think you have to find very special students, right? Because they're very busy. It's unbelievable how busy students are, and just trying to fulfill their requirements. But I think that I think it would actually be pretty easy to do if we decided to do it. I mean, there's administrative things we'd have to get back and get around and things like that. But I think if Annette and Alan and I said we're going to do this, we would make it happen one way or another, and get our students together. The students willing. What do you think?
Yeah, I mean, in the beginning I said to Tim, we should, think about this. To be honest, we're doing it already at MICA. In my Unravel the Code class. This is the 10th year anniversary. Besides that Ellen is there, we have a mechanical engineering class, we have a NASA system engineering class, and I always keep saying, I need them. The students need them. So we're doing it, and we're having quite some success. I do remember when, in the beginning, when Ellen came in, and the students were talking about that they want to have this piece flying over the top of the mountain and then come back and take photographs. And I just saw Ellen looking at me like, that's impossible. So that kind of tendency of saying no first, after 6 years working together, is not there anymore. He gets a little quieter, but it is, but to think about that that students can dream and really come up with stuff. We're doing it, right? And they're doing it in 15 weeks. So it is possible, and we have a model. I would love to continue because I think we learn so much from each other. I think what we have especially in academia, we speak one language in the class, and we need to expand that language. If we bring diversity in the sense of thinking, or even using a different language, we should. And we're all tinkerers, so especially artists. So Why not tinker together?
Yeah, and I like to expose my students to art and music. I play a little violin and do some fiddling and stuff like that. For example, I was creating a PowerPoint lecture because we had to go online. We all of us here experienced that. And I realized that the cover of my book looked exactly like a Mark Rothko painting. It had the same color. So I found a painting, and when I did my lecture, I morphed it into the Rothko painting. And I said, you know, this is going on in the 50s. What else was going on in the 50s? Oh, John Cage was composing 233 in the 50s to get my students to think about what's going on in the greater world. This semester, I've got a little project going. What are we all wearing today? Masks, right? Masks have been around for thousands of years. So I have a collection of masks at home, and you know, like Annette said, learning through doing this thing. I learn by collecting things and finding out what's out there and what people have done. So I'm bringing in a new mask every week to my lecture to show the students how people have seen masks in different societies and different cultures, and it's a lot of fun. They're looking at me like I'm really strange because this is a mechanical engineering course. Why are you showing us this? And the whole idea is to get them thinking about making a connection that wouldn't be there. And I think that's what we can do with these types of collaborations and getting students together. Make new connections and really see that we're not that different, even though the outcomes may be.
Another question. Yes.
So I have an art and engineering question. And it's to do with the materials used for cleft. Those plastic units that are all bolted together. How many bolts? That was a lot of bolts. A lot of bolts.
So
We actually know how many.
How many bolts?
90 in each segment, so
15 segments.
1,350.
So those plastic segments, how were they, did you design them? I don't see them at Home Depot. Like, were they designed and how did you make them and what are they made out of?
Well, Timmy didn't make them. Annette did. So Annette.
I was looking for a design that were elements that I could handle by hand, that could make complex forms. So I started doing research in some kind of architectural forms, looked at my own field, like lace, how lace was made and how you make connections. And I actually went to Bath & Beyond and started feeling all the cutting boards. I was like, cutting boards, that's it. So I felt all of them, and they looked at me if I was a little weird, but looked on the back and was like, oh, this company. So I wrote the company and I said, what is this? Because I didn't know what it was called. And they told me, and I ordered it through McMaster-Carr. And I did a design in Rhino and cut them on the CNC. And it was actually pretty straightforward.
You cut each segment yourself. And did you say made out of cutting board material?
It's a polyethylene
Polyethylene.
material. What is basically when those cutting boards you have in the kitchen.
Yeah.
I was like, oh, that's flexible, that's pliable. I can move this around. So I look for materials that I can handle, that I can manipulate by hand.
And when you bend it, does it keep its shape or does it try to snap back?
Well, it pretty much keeps its shape. Yeah.
I just want to reiterate that Cleft is all Annette's. It came to me, and I think Alan, finished. That's why I said it was a retrofit project. But I absolutely love that it was made out of polyethylene, because I've worked with polyethylene because it's a major component in artificial joints. So I got some in my hip, I got some in my knee, but I've done research on artificial joints for longer than I want to say. So that was just kind of a bonus. That polyethylene does some weird stuff. It creeps, which means it'll hold a shape, and then you think it's changed its shape, and you come back a couple of days later when you take the load off, and it's back to where it started. And it is really durable. I think there was one that was. I didn't do it. It was broken when it came here.
I start to question that now. But
No. And it is pretty durable stuff,
Very
and it's
durable.
like perfect for. I mean, Annette really hit on. Her research gave her this ideal material. It's really kind of cool.
And just that there are 3 vitrines, right, of her studies and testing and things like that included in the exhibition, so you can get a glimpse of what she was up to in terms of her testing. Also, there's a biomorphism aspect to the Y connector and how it allowed her to create
Totally.
volume and sustain volume. There's also another whole nother narrative around how Dutch lace collars are kept in a flat. There are flat forms until they're starched and worn. So anyway, so it's just very interesting. We have another question. Yes?
Alex, could you speak about the movement, your choice in the movement? As I'm looking at it, I'm imagining all sorts of different
That's beautiful.
organisms and other things, but I mean, what was inspiring you in selecting these particular?
I think the research during my Smithsonian was really important to really look at fish and how they would move around in water. So in the beginning, even when I spoke with the first group of students, I kept saying, and I sent them some animations actually, if you drop a pebble in the water, that kind of slow movement, right? It was one of the things that I sent them. So I showed them some things that I am intrigued by. It's like cause and effect. The idea of when you put clothing on your body, that slowly, the movement of the folds, all those things, and then thinking about the fish in water. But clothing too, in the sense of how it moves with us, how it, leaves behind folds in the fabric that are particular for me. So I was thinking about those kind of things.
And the renourish forms, right? So there are also biomorphic tree structures on the dowel side, but then the rondelles, right? The jacquard imagery, right, is not unlike, observing fish in some kind of a body of water, and that's a way to interpret those forms. And Annette is thinking about those things. So
I mean, we all know that nature is amazing, right? That it has these forms and structures that are so inherent in natural forms. So I look constantly at forms that I'm thinking, wow, how would that work within a sculpture? Or how can I translate that? Or how can I bring that actually into the computer space? I think a lot about how I can bring structures in the computer space, use the computer to really start thinking about then how to make. And that translation for me is really important. I'm not as interested in the image in the computer itself, but I'm more that I'm using it as a tool to start making. And that's what most of the works are in this show about, in principle.
totally. Well, it's 8:00. Oh, Sylvia, yes, do you have another? Okay. So thank you, everyone, for coming. Thank you, folks at home, at YouTube, in YouTube land. Annette, Lynn, everyone. Thank you, Alan, Miles, Timmy. It's really great. Beautiful. Oh, and thank you, technicians. Really beautiful job. All right. Good night.
Good night, thank you.
Everyone. Beautiful.
Good.
If anyone wants to look at the lovely
Yeah, pass
pieces
it
of
around.
hardware,
Show and tell.
Really great. Really helpful. It's a good, Annette.
Thank you, Miles.